Here in calorimetry, objective number 1, the question number 1. Here, the specific heat capacity of a body depends on the heat given, and B, the temperature raised, and C, the mass of the body, and D, the material of the body. So which one is the correct option among all the four? So first of all, what is meant by the specific heat capacity? That is specific heat capacity or specific capacity. So here the quantity of heat required by unit mass of the material to raise its temperature by 1 degree centigrade. That means unit mass and 1 degree. Unit mass is nothing but 1. Here 1 degree is nothing but 1. So what is that here? Q is equal to ms delta T. That means in this S is equal to Q by m delta T. Here mass is 1 unit and this one is also 1 unit. That means 1 unit of mass raise its temperature to 1 degree centigrade. How much amount of heat which is required? That is called as specific heat capacity. So this, what are the units for this one? Q measured in calories by gram degree centigrade in CGS. In SI system, joule by kg Kelvin. Here to convert these two, 1 calorie by gram degree centigrade is equal to 4.186 joule by kg Kelvin is equal to converting into that one 4.186 joule by kg Kelvin is equal to 4200 joule by kg Kelvin. So this is the conversion. Now what is the answer among all these ones? So here in the given definition only, the quantity of heat required to raise the unit mass of material to raise its temperature by 1 degree centigrade. That means here mass is 1 unit and temperature is also 1 degree. So that's why the specific heat capacity of a body depends on only the material of the body. Here the question number 2. Water equivalent of a body is measured in option A kilograms, option B calorie, option C Kelvin, option D meter cube. To answer this one, first of all we have to know what is meant by the water equivalent. So here water equivalent of a body, the mass of water whose thermal capacity is equal to that of a given body is called water equivalent of that particular body. So here thermal capacity is nothing but heat capacity. That H is equal to m into S, heat capacity. Now here first of all, to understand about that, I am taking one body. For that body I am supplying the heat delta Q1. The mass of the body is taken as m1 and specific heat of the body is taken as S1, and we have to raise the temperature up to delta T1. So here delta Q1 is equal to m1 S1 delta T1. Here I am taking another water. So mass of water is taken as m2 and specific heat of water is taken as S2. That is, the value is 1 calorie by gram degree centigrade. We have to raise the temperature up to where, how much amount of temperature we are raising for this body, same amount of temperature we are raising by using the heat delta Q2. So delta Q2 is equal to m2 S2 delta T1. We are equating delta Q1 is equal to delta Q2. So here equating those delta T1 those gets cancelled. Here m1 S1, but here S2 means already we know this one is 1. So here m2 is equal to m1 S1. This is the water equivalent. So here water equivalent of a given body is m1 S1 grams. Why? Because m2 is equal to m1 S1. It is units are grams. So here and numerically which is equal to heat capacity. That is nothing but calorie by degree centigrade is the unit. But here what are the units for water equivalent of a body? So water equivalent of a body is nothing but which one? m2 is equal to m1 S1 expressed in terms of grams. So that means in CGS system the units are grams, but in SI system the units are kilograms. So here out of A, B, C, D, which one is the correct option? Option A is the correct. Here the question number 3. When a hot liquid is mixed with a cold liquid, the temperature of the mixture, what happens? A, first decreases then becomes constant. B, first increases then becomes constant. C. Continuously increases. D. It is undefined for some time and then becomes nearly constant. So observe this one. First check the first option. First decreases then becomes constant. Hot liquid is mixed with the cold liquid. The temperature of the mixture. So here temperature of the mixture we can't say whether it is increases or decreases. So that's why first decreases then becomes constant is wrong option. Then B, first increases then becomes constant. This is also we can't say properly. Then C, continuously increases. Here one cold liquid and one hot liquid. So that means both are mixing means the resultant temperature must be greater than the cold one and lesser than the hot one. So there the resultant temperature may varies. So that's why continuously increases is not the correct option. Which one is correct option here? It is undefined for some time. After adding the hot liquid to the cold liquid, we can't say anything about the mixture. After some particular time interval only, we will see that becomes nearly constant due to thermal equilibrium. For this, what is the option? Delhi. D is the correct option. Here, the question number 4. Which of the following pairs represents units of the same physical quantity? Option A, Kelvin and Joule. B, Kelvin and calorie. C, Newton and calorie. D, Joule and calorie. So, which of the following pairs represent the same physical quantity? That means same units of physical quantity. So, first of all, Kelvin. Kelvin is the unit for which one? Temperature. Temperature. And calorie is the unit of heat, energy. And joule is the unit of energy. That is also energy, heat energy, kinetic energy, potential energy, that one. But here Newton, it is the unit for force. Which are having the same units here, calorie and joule. Those two are having the same units. But here which one are here? Joule and calorie. So option D is the correct for this question. Here the question number 5. Which of the following pairs of physical quantities may be represented in the same unit? A. Heat and temperature. B. Temperature and mole. C. Heat and work. D. Specific heat and heat. So first of all, whatever the physical quantities which are present, first of all I will write the units. Now here heat, that is calorie, and another unit is joule. Temperature, degree centigrade and Kelvin. Mole, it is the unit of amount of substance. So here mole, N is equal to mass divided by molecular weight. So here work. Work is Joule, joule, and calorie and air. So then specific heat. Specific heat is nothing but calorie by gram degree centigrade and joule by kg Kelvin. So among all these ones which are having the same units, here joule and here joule. So that means heat and work are having the same units. So that's why which is the correct option among all these ones? C is the correct option. Here the question number 6. Two bodies at different temperatures are mixed in a calorimeter. Which of the following quantities remains conserved? A. Sum of the temperatures of the two bodies. B. Total heat of the two bodies. C. Total internal energy of the two bodies. D. Internal energy of each body. So here first we will check the first option. Sum of the temperatures of the two bodies are conserved. So how it may be conserved? Because here what happens? Two bodies at different temperatures are mixed in a calorimeter. So due to that, what happens in this case? Attaining the thermal equilibrium. So that some of the temperatures of the two bodies cannot be conserved. And B, total heat of the two bodies is conserved. Here, heat also not conserved. Why? Because both are mixing at different temperatures, attaining the thermal equilibrium. Then C, total internal energy of the two bodies is conserved. Yes, it is conserved. And D, internal energy of the each body. When those two bodies are mixed together, internal energy of each body that should not be get conserved. So which one is conserved here? Total internal energy of the two bodies is conserved. Here the question number 7. The mechanical equivalent of heat A has the same dimension as heat, B has the same dimension as work, C has the same dimension as energy, and D is a dimensionless. Now listen, to answer this one, heat, work, energy, all are the forms of energies. So that's why all are having the same dimensions. But here remember, first of all, mechanical equivalent of heat means what is that? To know about that mechanical equivalent of heat, we should know that Joule's law. That is Joule's law and mechanical equivalent of heat. So Joule's law is nothing but the amount of heat generated, that is Q, is directly proportional to the work done. That means how much amount of work done you are doing, that much amount of heat is generated. So W directly proportional to Q. Here we are removing the proportionality symbol and we are using W is equal to JQ. J is called as Joule's constant, or otherwise it is mechanical equivalent of heat. So here if Q is equal to 1, then what happens? J is equal to W. So the amount of work done required to be done to produce a unit quantity of heat called mechanical equivalent of heat. Here the amount of work required to be done to produce a unit quantity of heat, that means unit quantity means 1. So that is known as mechanical equivalent of heat. So here J is equal to 4.186 joule calories to the power of minus 1, or J is equal to 4.186 into 10 to the power of 7 erg. That means 1 joule equal to 10 to the power of 7 ergs calorie to the power of minus 1. So this is the mechanical equivalent of heat. But here W is equal to JQ. J is equal to what is that? W by Q. Both are having the same units, but here J is the dimensionless. That means W by Q. That means both the units gets cancelled. There J is equal to constant. That is dimensionless. So that's why this is the D is the correct option for this question.